us share his journey, because he has been, he's the one who has been developing on blockchain since his college days. So let's have an inspiring, thought from Souradeep, and after that we can definitely take on the webinar towards the technical side. Souradeep, please.
Good. First of all, super happy to be here and meet all of you. Um, it's very pleasant, and I'm sure we can trade some of the anonymity parts today by having showing our faces on the camera. But yeah, good. So something about me. I, as Vinayak mentioned, I from my college days, I got introduced to Bitcoin. The Bitcoin white paper, like many of us, we were inspired by that, and that led us to blockchain and smart contracts and Ethereum. So back in 2017, while I was doing my bachelor's, I got introduced to Bitcoin, and then that led me to learn more about security and cryptography in general, which was very appealing. And then that led me to Ethereum because that was a big thing at that time. And information was very scattered. It was not at a single place, but luckily we have a lot of good resources these days. So yeah, after picking up on Ethereum, I headed a blockchain research lab in my college, also called the Next Labs. We mainly researched on blockchain, cryptography, homomorphic encryption, and stuff like that. And once I got to know more about the technology, gradually uh, I got gradually taken away by the complexity and the things that Ethereum can offer with a virtual machine. That led me to smart contracts, where I started with developing over blockchain, and then winning some hackathons here and there. All of these boosted confidence. That led me to go and lead the blockchain lab at UC Berkeley while I was a special student there, and got a chance to research on several of these topics, such as stable coins. You might have heard about them. You might have heard about uh, POS. There's a separate consensus mechanisms to in opposing to what we hear with proof of work. Got a chance to research on all of this, and then I did some work around building the blockchain ecosystem around India by being a student lead at Consensus College Consortium. And after that, I uh, aligned my interests, and since I layer two scaling solutions, which we'll discuss today, is a very close topic to my heart. I started working with ONG, and so yeah, I'm presently working with ONG for more than a year, 1.5 years, and we are working on making Ethereum more scalable. Uh, we're making Ethereum more powerful. We're trying to enhance the existing way to scaling solutions, and make the whole blockchain ecosystem better. Some of these words might not have made sense, but I'm sure if you stick with us, we'll probably get to know about all of these. So yeah, passing on the mic to Vinayak, and let's get started.
Yeah, definitely. We'll try to clear those terms that you have said, right? And we'll try to, answer as many questions as possible regarding the, blockchain ecosystem itself. I might trouble you in between a lot, Souradeep, so that, you can share some of your experiences with the developers that are here. So let's try, moving on to some of the technical sides now, right? Let's try and keep this session very interactive, right? I love people who interact, right? So let's have a quick question right now. Let's see how many people are amongst you guys. I think there are roughly more than 50 plus people here. So let's see how many of you will, reply to that question. So how many of you have heard about blockchain before we reached out to you guys, before Block Street reached out to you? Can we have a quick yes and a no in the chat box?
It's very interesting.
Great, great. Okay, but still, okay. It's a yes. It's a yes. Yes.
The
Okay.
consensus says yes.
Yes, that huge. Okay. So tell me one thing now, that how many of you have actually, worked on a blockchain before? How many of you have actually developed something? Maybe it's just a basic tutorial or something. How many of you have done that? If you guys can reply with a yes or a no. so that we understand that what is the audience that we're talking to about. No, a huge no. Okay, everybody has heard about it, but nobody has done anything in it, right? Okay, no, no. But I understand that these no is that you find it difficult to get started. Otherwise, if you've heard about it, and if you've heard about it right, you must have understood that there are a lot of cryptocurrencies. The prices of those currencies have risen from nothing to something, right? And some of the currencies have made 10x in their prices, 100x in their prices. Now this is just about the currency part of it, right? The technology behind that currency is most of them is blockchain, right? So has never this particular thing has enticed anybody to go towards blockchain. Like so much money is there in this particular field, right? Will show you like how much more could be made out of it. So but yes, right now you guys are all here, so you are all interested in learning about blockchain, what it exactly is and how to get started. So what we will do is try to convert this no to a yes, right? Let's see how can we do that, right? Let's try and understand what blockchain is, the basis of all of the things that are being built, right? We'll try to make this very very crisp, so that you guys can understand the terminology that there is, right? And then you can read anything and then compare it with this session, so that you understand what exactly is it that you're reading about. All right, so let's start the session. In this session, what will we cover? So we'll try and go through a very very basic functionalities of blockchain. What I'll do is I'll try to correlate the existing system. Like I think a lot of you might have worked with MySQL tables, right? A lot of you might have built some websites, built some applications or something. Again, let's have a very very quick yes and a no again, right? As I have told you, I like this session interactive. So how many of you have actually built an application? Like it could be on Android, could be on website, right? Can we have a quick yes and a no here? Right? A lot less replies right now. Okay, okay, it's building up. All right. It's a no from a lot of these people. Okay, there is one Paras. Okay. All right. So okay, and all right. So the basic knowledge, I think you might know tables, right? You know data structure. Can we have a quick yes and a no for data structures? If people know about data structures. Yes. Okay. Yes. Yes. Data structures. Fine. Then we'll have an analog to the data structures then. All right. Just uh, about the functioning of a blockchain. Blockchain is nothing but a unique way of storing a data, right? So we'll gather information about how is this unique and what could be the possible ways that a blockchain could be used for, right? So the users will take care of that particular thing in the users, right? Then we'll focus on Ethereum and the basic building blocks of Ethereum. By Ethereum, right? Then we'll start with the session. I'll explain you why Ethereum is the most important thing right now, right? And why is it important for this particular webinar, right? And then as a developer, how can you get started? Like, as I've already told you, I want to convert those no's to a yes, right? So we'll try and focus on how, as a developer, can you guys get started. So if we let's try and understand what a blockchain is like, right? So a lot of you might know what linked list is, right? It's not exactly similar, but you can take an analog to a linked list where a data from the where basically a chain of events happen, a chain of data is being formed, right? One data that starts it is being linked to the second one, and the second is linked to the third one, and so on and so forth. This is what a blockchain actually is. This is what the term actually means, right? Now let's see what are the different constituents of a blockchain, right? Let me, okay, I might have to, right? So let me tell you about the basic building blocks of a blockchain. Now this is first thing. This is hash, right? Let's in hash. What happens is This is a one-way cryptographical function, right? So if you feed this function a data, it will convert this the particular data into 32-byte hash, right, to 56-bit, right? So what happens is that the data is being converted into hash. Now this one-way function converting data into a hash is a singular way. How so? Because it is very much impossible to convert this hash into this particular data. Supposedly I have a data here, like, you know, supposedly I have a hello world here. So this particular data now has a hash here. So this is the hash value of this data. But using this particular hash, you cannot really get this data. To get it, you might need a lot of computing power. So whenever I type hello world, in this specific way that I did, so you can see the hash will remain the same. So once the data is been fed to this function, the hash always remains the same. The only thing is that it is irreversible unless you apply a lot of computing power to it. So that is which is practically not possible for me and you to do, right? So this forms the basis of security in a blockchain. This is how a data is secured. When you feed a data, it will convert a hash and it will always be the same for that data, but you cannot reverse it back, right? So this is how blockchain achieves security, right? Now let's talk about what exactly is a block, because blockchain comprises of chains of block, right? Let's talk about what a block is. So all of this data is what is inside a block. This is block height. Now number of block, like this is the first block, the second block, the third block, or the fourth block, and so on and so forth, right? And this is nonce. During mining, what happens is that we need to guess the nonce value of the block that there is, right? So basically this nonce is used to guess, actually this nonce is used to guess while mining, right? And while mining, only when this particular nonce is guessed, only then the block is validated, right? And so now this particular data, this resides in the block. This hash is being converted using all this data in the block. So this is block hash, the hash of the block, right? So if I change the data here, the hash changes, right? So what you need to do is whenever a data is inserted in the block, what we do is we mine that block and insert it into the blockchain, right? So this it is not as simple as it looks right now. This specific thing, this is open source, and this is only to learn about what blockchain actually is. It just tells you about the concepts of it. This is not the exact process of mining, if I am to say, right? So this is not the exact process of mining. Okay, so this is what a block is. This is how a block is mined, right? Let's now see what actually a blockchain is. It's simple. It's actually a chain of blocks, right? And it is linked via this, like the hash of this particular block is been fed to a variable here, which is previous hash, right? So if you see, these two hashes are similar, right? So this particular block is linked with this block with this hash. So what will happen if I change the data here? The hash will change, right? So that's the thing. The hash will change. If you see the blocks, all of the blocks turned red from green. That is this is why, because all the blocks were invalidated because I changed this particular block. So this hash is changed now. What I need to do is mine this block and mine this block, mine this block. Only then, these blocks will come into sync. This is what blockchain works on when it comes to security. So if you change the data, if I say, like, I want to change the data in a block, I want to change a transaction in a block, I'll go back to first block or to the second block and I'll change the transaction there. So if you change the transaction there, what will happen is all the blocks that are after that particular block will change, signifying that there has been change in that particular block. So what needs to be done is we need to mine all these blocks. What will happen if I do not change this block? If I change this block only, right? So only this particular block will be invalidated, not all the blocks. This is how blocks are linked, and this is how the data is secured. Because if you go and change data in any of the block, you need to change all the blocks after that. So this is the basis of transactions in Bitcoin. If you transact in Bitcoin and your transaction has been accepted in a block, after 6 confirmations, it's practically not possible to go and reverse that transaction, or for that matter, change that transaction. Because if you change it, the blocks ahead of the chain will be invalidated, right? And this will invalidate the chain, and from there on, a new chain might appear. So this is how this forms the basis of data security in blockchain, right? And now, because this particular thing, this is basically data here, so I can enter sentences here, or maybe what can I do is I can enter some JSON objects as well, right? This is data. You can basically write anything here. So in the case of Bitcoin, what happens is, in this data, we write transactions, right? In the blocks, what we do is we store transactions, right? In a lot of chains, we do this. We store transactions, and even in Ethereum, we store transactions. But I'll come to it. Like, Ethereum has a unique capability here when it comes to data storage, right? In Ethereum, what happens is that what you can do is you can even store contracts here. Those contracts are basically code, and you can store code here. And Ethereum has a very good feature, that Ethereum has EVM, right? Ethereum virtual machine, where what happens is, during basically EVM executes the code, and it sends you the desired output that you want. You basically, what you can do is, through that code, you can store data, change that data, right? Because this is just code, right? You can change data, you can store data, and even you can get the data, right? which uh, which forms the basis of programming in Ethereum chain. This is why we have chosen Ethereum as our motive, as the chain which suits developers the most, because it is a programmable chain where you can deploy code and then interact with that code, right? Where, and as I've already told you guys, it's just a way of storage of data. So in Ethereum, the storage of data happens like that. You can basically compute on that data as well using EVM. Ethereum has transactions in its chain as well as contracts in its chain, where you can interact with those contracts. Those contracts are the code, right? uh, Here, till this particular point, has everybody understood? Please, can we have a quick yes and a no here? Okay, we have a question as well. All right. If someone gets function for converting to hash, uh, no. If someone gets a function for converting to hash, even if it is SHA 256 or SHA 512, even if you have that, you need the data, right? To retrieve it. Even if you have the function, and if you have the hash for that matter, right? There is no way that you can retrieve the data, uh, because this is a one-way function. There is no way that this particular hash can be reversed in that function. So no, this is something that is not possible. Yeah. If please, let's have a quick yes and a no if everybody has understood this particular part. Okay. Very few interactive people right now. Okay. Still waiting, guys. Be interactive in the session. Let me show you something. I think that might, okay. Okay, this is a yes from most of the people. All right. So let me show you something. It might, pique the attention span of everybody now. Let me show you some of the contracts that are made, right? So now this is something that we cover in the use cases as well. Now, these are some of the dApps that are created, right? So just have a look at the value logged in these contracts. Now, these are some of the contracts that are built on the Ethereum chain. This is what we are talking about here, right? And see the logged amount in all of these contracts. These are in billions. Now, the B stands for billions, right? So what we are teaching right now, right? And somebody out there has executed it, made billions out of it, right? Not billions, maybe millions, but yes, this is the total value logged in all of these projects that you see here, and all of them are are DeFi projects, decentralized finance. right? So if you see the value that has been created, now all of these things has been created by developers like you, right? Now what I believe is, you guys are smart enough to understand that, and you guys are smart enough to actually deploy something like that, that can create something like that, such value, right? Now if I might, there might be a, as well as this, and this is just the DeFi that has so much value, right? Then the another part is NFT. This is the basis. This is also something that blockchain uses blockchain for its construction. Now just have a look at it. I don't really know how many of you know what the price of an ETH is, right? But just have a look at it. That this is 5,000 Ethereum, right? And the 5,000 ETH, I think an ETH is right now about maybe it's about 1.5 lakhs. Just calculate it in your mind and see what value there is, right? In all of these things, in all of the things that we are talking about. If this does not pique your attention, guys, right? So this might not be the thing that you want to do. All right. So what I'll suggest is that stay active, and we might uh, learn something here regarding all of those things, that how this value has been created, and how can you as a developer create it and make it for yourself, right? So these are the uses of blockchain, right? We have DeFi here, we have NFT here. I've already shown you some of the projects on DeFi. But decentralized finance actually is, let me explain it to you in a very layman language. Decentralized finance is just uh, but the concept, let me tell you guys about the concept of decentralization. Decentralization, what exactly that is. Right now, you might know about the data structures that you guys have. The data structures, what happens is that all the data is stored in just a singular place, in a centralized server, right? But if your data is stored in multiple nodes overall, right, and you can basically contact any node and get that data. Now this concept is decentralization, where you decentralize, where you distribute the power amongst people. Now all those nodes that contain that data are nothing but you and me. So what we can do is we can run those nodes here of the blockchain. Now this was only possible because of the technology blockchain, where the data is stored in a very unique way, right? So that is how decentralization came into picture, that let me run a node, let me download the whole chain, and I will be a provider for the data, right? And to provide that data, definitely there are incentives. Again, we'll definitely not go into that much detail. It's just an overview of things here, right? Now in what happened in DeFi, decentralized finances, that right now what we have is a central body bank. Like if you want, what your you might open your accounts, like you might open your bank accounts and see this, you have 10,000 in your account right now. Now what that 10,000 is, that 10,000 is nothing but a number in a database, right, of our bank. Now that could be changed. If I somehow, if I had access to that database, I can go there and change that number, and you'll be left with zero for that matter, right? So the point being, what if this power was not in the hands of bank, but if this power was decentralized, but if this power was held in the power of the people itself, right? So there was the concept of decentralized finance, where we have the power distributed amongst a lot of people like you and me, right? So this was this what this ensured was security of the user, security of the of your funds as well. So this is how this forms the basis of cryptocurrencies that we see right now, right? The another use case of blockchain is NFT, as I've already told you guys, shown you guys. Now what exactly are NFT? A lot of you might be wondering what is NFT. So NFT are non-fungible tokens, right? So there are two types of tokens: fungible tokens and non-fungible tokens. In fungible tokens, what happens is, uh, basically, let me give you a very simple example, right? Now, when you go to a market with a 100 rupee note, the shopkeeper will and tell the shopkeeper that you want 10 rupee notes, right? Now those 10 rupee notes has the same value as that 100 rupee note, right? This means that that 100 rupee note is fungible. It can be broken down into minor parts, and then that minor parts will have the same value as that 100 rupee notes. Right now, this is fungible. That 100 rupee note is fungible, but exactly is non-fungible. Supposedly, you created a painting, right? Now, in the world, nobody could duplicate that painting, or could divide it into very smaller parts and then say, yeah, this forms the whole painting, right? So this particular thing, it's non-fungible, where you can cannot really divide it or formulate another value for it. So this is non-fungible. So all the NFTs that you see here are art pieces, right? In cryptocurrency, what has happened in blockchain is that they have created such a space where we can create an NFT, right? We can create such designs here, and we can sell it here in this marketplace on OpenSea.io. Even you as a designer, even if if people like you, there might be some people in this lecture as well who likes to design things, right? So they can design things and upload it here, uh, to be sold. You can see here a lot of designs are here, a lot of arts, right? And right now, if you even see the latest recently listed, you might see what all are there and how people charge here. You can actually buy stuff from here and then use it. And these NFTs are limited at the are limited as well. Like, you can only buy so much. It could be 100, it could be 200, maybe 1,000. This depends on you how much you want to create it, right? So at the same time, if these are scarce, right? These art pieces are scarce. So all of these things, you can see, prices are listed here, are being sold here in this marketplace. Now, this is one use case of blockchain, right? The another is cross border payments, where you can send payments. If you're in India, you want to send payments to uh, you know maybe America, maybe Canada, you can actually do that. You just have to send a Bitcoin from here to there, or Ethereum, or maybe for that matter any cryptocurrency, because all of those cryptocurrencies, they work on a peer-to-peer manner, right? So what peer-to-peer means is that I can send money from here to somebody that is out with, and I'll have to directly interact with that guy, right, to send money. I don't really need a medium in between, right? A central body in between, not a medium, a central body in between, which takes care of the transactions for me, right? So in blockchain, what happens is that medium, Bitcoin or Ethereum or all those cryptocurrencies, all those chains, they become the medium. But you being in control of your money, not a central authority, because none because there is nobody controlling these chains, these decentralized chains, right? So these are the uses of blockchain, right? Let me Okay. Then we have Web 2 and Web 3, right? So in what happens, I think this is a term that who have heard about blockchain might have heard, like, this is Web 3, this is Web 2, this is Web 1, all of those things. So let me clarify what Web 1, Web 2, and Web 3 are. Right, in Web 1, what happened was, there were basic infrastructure of the HTML and CSS. I think a lot of you might be familiar with HTML and CSS. There was a basic structure of HTML, CSS here in Web 1. And in Web 2, what came into picture was cloud computing. Right now, what you can do is create servers, create Node.js servers, or maybe if you are into development, you can create basically, this what this means is that cloud computing came into picture here, where we can create and deploy servers, right, and make better applications. All of the social networks that we have right now came in Web 2, right, where the information was being shared with everyone, right? And information was, right now, what happens is that if you get on social media, you're basically sharing information with other people as well as with the service providers as well. So in Web 3, what is going to happen in Web 3? In Web 3, a decentralized data structure is going to come into picture, where the data, where and as well as provide you privacy of your data, and provide you privacy with your data. So this is something that is going to happen with Web 3.0, right? And only this is only possible if we have blockchain and the decentralized data structure along with us, right? So all of these things, and you can see this graph is basically based on the market value of all of these three. So you can see this is on a rise, and along with web 3.0, this is going to rise. So it is very much essential if you can start developing on Web 3.0, Now Web 3.0 is nothing but you have to develop on decentralized applications where security, right, and privacy are paramount, right? So this is a basic introduction of what Web 1, Web 2, and Web 3 are. All right. And I think I've already covered what Ethereum exactly is and how a smart contract comes into picture when it comes to Ethereum. Ethereum is a programmable chain where you can program your code, and you can deploy it using like a transaction on the chain. I think we have covered that particular part. Let me show you what a smart contract looks like, right? And this is how a smart contract looks like. I think a lot of you might know Java, right? What I have done is, I have always, thought of smart contracts analogous to Java. It's not that difficult. That you can see that what this is doing is this is just storing a data, right? Storing a data, stored data, and it is, getting this data. So it's just storage of a data and getting a data. This is what a smart contract is. And you guys being developers of, most prestige one of the most prestigious universities in India, I think a lot of you might find this very easy. And trust me guys, if you go ahead, deploy a smart contract, you can do that in a couple of days only, right? You don't need more than that, and I don't think so you need more knowledge even to deploy a smart contract, for that matter, on a Ethereum chain, right? So this particular code is sent as a transaction on a chain, and then EVM compiles it and then sends the appropriate data back to you. This is what a smart contract is, and this is what how all those protocols that I showed you, right? How all those protocols were working. So this is something that is that forms the basis of it, and this is something that you should uh, use to get started. Developing a smart contract is something that is something that, but I feel, is a developer should get started by, because this is the easiest part of all the parts, all the other parts that you'll acquire along with the your journey. But understand how a smart contract is deployed on an Ethereum chain, and in a couple of days you'll understand how things are working, right? In practicality, right? So I urge Souradeep to to contribute to it, and take the limitations of Ethereum network from here, guys. Quickly, I'll let you guys know that as Souradeep has already told you guys that OMG is working on scalability solutions for Ethereum, but the current limitations of Ethereum network are catered by OMG, and it is one of the reputed projects in India. So what I'll urge you guys is have a listen through as to what Souradeep has to say, and then definitely form out your questions and you can ask them later in the session. Souradeep, over to you.
Awesome. That was pretty interesting. Uh, bit. So before moving on, should we address a couple of questions that we already have? Vinayak?
Do we? Okay. Yeah,
Good.
sure.
I'll just read them out to you and probably add in more information if
Maybe,
so we get a good
maybe,
answer.
maybe Souradeep, you can take those questions. That would be good as well.
Perfect. Perfect. Yeah. So the first question was, what does setting a tweet as an NFT mean? Like Jack Dorsey recently did. Why wouldn't I just take a screenshot? Like I just right click, save it as a PNG, and maybe make my own token. Why can't I do that? So the concept of NFT is very similar to a token, right? So NFT is also called an ERC 721 standard. So an ERC 721 is a type of token. And as Vinayak mentioned, that it's a non-fungible token. Uh, that's non-fungible token NFTs. So what comes with NFTs are that first of all, they're unique. So they cannot be a second type of it. Given why? Because there's authenticity, right? You only your private key or only your address can mint an NFT. So let's say Leonardo da Vinci created a painting, and he made it an NFT, and now he has to sell it. Right? So he made a Mona Lisa. It's almost similar to the second question. So he made a painting, and then he wanted to sell it as an NFT instead of just selling the whole framed art thing. So what would he do? He can mint an NFT. It's as simple as creating a token. It's as simple as creating a token of yours. This in the market like OpenSea, and then it gets sold. And what can you do? You can right click and save it as a PNG, and you can make your own Mona Lisa just the same, right? I mean, you don't even have to replicate it because it's the same picture. Why does it make a difference? Because the person who minted the Mona Lisa or the painting was from Leonardo da Vinci's address. So it wasn't some random address that you picked, which generated the PNG. So the authenticity comes from that. So there are several other use cases as well, in addition to digital art, where NFTs could come in. Because with owning an NFT, you say that you prove, or you say that you own something which is unique and which was made by someone credible, or which has its own proof of authenticity, like we want to call it. Um, I guess, yeah, I guess the second question was almost similar, but yeah, cool. Anyway, let's move ahead and tackle a bit of Ethereum again. So, um, Vinayak explained to you how Ethereum is better as a blockchain, what all blockchains that we had in the past, and how Ethereum has EVM support, which is essentially smart contracts. Smart contracts are basically business logic, right? So you try to create an application, you need some logic behind that. And since Ethereum is a Turing complete framework protocol, you can actually make smart contracts in Ethereum and deploy it just by sitting in a sofa. You can create a financial system in the world. Isn't that interesting? But I would like to be a puppy shooter here. I would say that it's not all rainbows and fun, right? There are some problems. Nothing is. It's a new technology compared to everything else. There are problems. There are ways to get over those problems. So yeah, one problem that we can talk about, which Ethereum has, is scalability. So firstly, you saw how transactions were created. And let's say if I wanted to send a transaction to, say, Ankit here, because he has his video on. So if I had to send a transaction to Ankit, I would have to pay some gas fee. So what's the gas fee exactly? So the gas fee is a fee, or a charge you pay for using the EVM. So you don't clog up the network. You don't do a toss attack. So you pay for whatever compute you use. That way, everyone's incentivized to not act stupidly and take up a lot of gas and clog someone else from using the system. So you have this gas fee, and it depends on the amount of computation you're doing. So let's say for a simple transaction, the transaction is, let's say, from A to B, from myself to Ankit. I would need around 21,000 gas, and I have to pay some gas price for it. And what and how is the gas price exactly determined? So Ethereum has automatic difficulty maintaining mechanism where the gas price adjusts itself according to what people want to pay, which depends on the number of transactions that are already there. So we heard about miners, right? The ones who were mining the blocks in the first slides. So these guys, they mine. What will they mine for? They, of course, mine for rewards. The rewards come from mining those blocks plus the transaction fees that you give to them. Now, what if there are 100 people and there are only 5 miners? Now, all of them need to send a transaction and all of them want to send it as soon as possible, right? Why would you want to wait for it? So how do you compete? You say, I'll give you more gas fee, I'll give you more transaction fee, please take my transaction first. It's a way of saying it through increasing your gas fee. So when there's a lot of transactions in the Ethereum chain, the Ethereum network, for instance, we talked about dApps, right? So there was this NFT dApp, CryptoKitties, which really clogged up the network because there were so many people buying NFTs, buying digital cats, digital arts, and so many transactions that went in, right? So that definitely means a lot of users want the transactions to go through, but the miners were the same, right? There were no new miners because mining is a computational process. You need resources for that. So yeah, so gas fees increased. So there are 1,000 people now instead of 100. So everyone's paying a lot more than you. So you stay back. So you gradually try to increase your gas fee again because you don't want to wait that long, right? So that way, Ethereum, whenever there's traffic, Ethereum has a spike in gas fees. So that's a really bad problem because let's say I wanted to send $10 to you, Why would I spend $10 in transaction fees? Um, yeah, and scalability, the other part of the problem, which is very closely related to that. So what does scalability mean? It means throughput, how many transactions per second. You might have heard about Visa or MasterCard, which are like centralized payment solutions, right? And these process millions, if not billions, transactions per second. And we need that because if there has to be a payment network which needs to operate with everyone in the whole world, maybe to use it, we need that kind of throughput, right? We need transactions to go in faster, to have to process more transactions per second. But Ethereum kind of fails around that. So there's a block gas limit. So we talked about gas. Now, in every block, you can't exceed the gas limit because there's a hard cap on the gas limit because otherwise, people would be specifying any huge number of blocks, and that's technically very hard to propagate within each other because in a distributed system like blockchain, we need to send blocks to one another, and so everyone has the same record, right? There's no central compute. It's the whole concept of decentralization where everyone has the record. So we need blocks to be fast. So we have a hard cap on block gas limit, and now if we have a hard cap on block gas limit, we have a hard cap on the number of transactions that each block could have, right? So if there's, say, each transaction takes 5 gas, just for example, and the limit is 100, you only can have 20 transactions in a block. So you can increase more, possibly. So what OMG is trying to do, or has been trying to do, is solve this problem of Ethereum, of making Ethereum more usable by scaling Ethereum and taking transactions off chain and lowering the gas fee. So me and you can easily transact or use Ethereum much more scalably and in a better way. So the first thing, we're going to take it easy, okay? Just ask if you have any questions. It can be anything, but yeah, let's probably get a vote again. Should I start with explaining what OMG Plasma is, or do we need some more time with scalability as such? Let's do a vote, quick vote of yes and no. I think everyone's either scared or we have a complete yes. Yeah, so in that case, I'll quickly go over. It's definitely overwhelming. Don't be scared. It's definitely overwhelming. There's a lot of things. You just knew about blocks today. So we're not going to talk more technical now. Just going to be simple. We're going to give analogies probably to explain what are these stuffs are. So this name might sound complex, OMG and Plasma. What else Plasma, right? But yeah, let's try to simplify it for you. So we just talked about how Ethereum is unusable because of these reasons, right? There's fees, there's less number of transactions. What can we do? So the thing called Plasma is just a name for a framework which takes transactions off blockchain, of the main Ethereum chain, and then, just for example, say I'm the Plasma operator, so I operate Plasma, and you guys are transacting on Ethereum. Now you have these limitations. So what I do is I open a channel for you. Channel is probably an incorrect word, but yeah, I open a medium for you where you come in and send me your transactions, or you give me your transactions. I collect them together. I create my own blocks, and my blocks can be played up because I am pseudo centralized, but we'll come to the security part later. So what I'll do is I'll take all of your transactions, put it in a single block, and make it one transaction to the Ethereum chain. So I'm going to take all of your transactions, converge into one transaction, and commit it to the Ethereum chain. That way, we have all our transactions in the Ethereum main network, and we also have all of our transactions, and that too in a single block. So the way OMG Plasma works is you have these transactions, but they are not centralized since I'm taking care of it. There's a fraud proving mechanism. So let's say if I act maliciously because I want to steal your funds, you are making your transactions through me, and I can always steal your funds and pay you nothing, right? So there's this fraud proving mechanism. So what that means is basically if I do something malicious at my end, because I'm committing my data to the Ethereum every block that I'm making, you can always go ahead and prove cryptographically that I did a fraud, and then your funds are always safe. So even though there's an operator managing the transactions at Plasma, you can always have your funds safe with a lower transaction fee. So I'll give you a number about how low the transaction fees is. So for Ethereum, while DeFi boom or CryptoKitties era, the peak gas level times, you had to pay around $100 for a transaction, which is quite a lot if you ask me. I mean, if you want to send $50, why you want to send $100 as transaction fees, right? But in ONG, since we have our child chain, which is the layer two on Ethereum, you can actually make a transaction, Ethereum peer-to-peer transaction, with around 25 cents, that cheap. So yeah, so Plasma, right? So we talked about low fees and high throughput because since I'm creating a block and we didn't talk about a Merkle tree yet, maybe that's a pointer for you guys to check it out. What are Merkle trees? I'm not point out keywords right now. So yeah, just know that a Merkle tree, I put all those transactions in a Merkle tree and I get the Merkle root, which is a proof, let's say a proof, and I submit it to the Ethereum blockchain. So I'm not submitting every transaction to the Ethereum blockchain. That's going to be expensive. We're going to come to that in the next slide. So you're not going to put every transaction on the blockchain, but a proof which you can go ahead and say that, yeah, this block had my transaction, see, and this fraud was committed. So there can be high throughput around 2 to the power 16 transactions in a block because it's a Merkle tree and there's not much computation in that. So these are like huge things, right? And then what about smart contracts? We talked about smart contracts, how they're useful. They're just code, magical code in the blockchain. But can we do that on Plasma? Well, uh, let's move to the next slide and find out. So we, it's really hard to have smart contracts on Plasma because it doesn't have EVM support. So we have something called predicates, but it's very tough. So we just can safely say that no, we don't. ONG Plasma doesn't have smart contract support. So what we did was we tried to build an optimistic rollup which have smart contract support, which have EVM support. It's based on the optimistic rollup virtual machine. Uh, it's quite similar to the EVM, so it allows you to use smart contracts on a layer two like Plasma. So optimistic rollups may sound something very complicated, but it's very similar to Plasma. It's almost a lot derived from Plasma. There are certain differences, but yeah, the basic idea is we have EVM, we have OVM on optimistic rollup, so we can have smart contracts. Though there are some trade-offs, though, that slightly higher fees and little bit lower throughput, which Plasma is probably better with. But yeah, I mean, you lose some, you win some, and and yeah, I mean, let's not talk about data availability, but yeah, so Plasma has been live on mainnet, so you can actually use it if you want to send, say, um, zero point zero 0.01 Ethereum to your friend. Why would you do it on Ethereum mainnet? You can always go to OMG.network and use the wallet to send that over Plasma. It's fast, it's cheap, and optimistic rollups. We have the testnet running now, planning to launch it soon. So you guys can also create smart contracts on optimistic rollup. So what's the advantage of creating a smart contracts on optimistic rollup over Ethereum? So in Ethereum, when you create a smart contract, you're saying people are going to use the Ethereum main chain for using your product, right? Whatever you build. But when you're launching a smart contract on say optimistic rollup, you're going to say people are going to use my app on optimistic rollup, which has the same security of Ethereum, which is just a layer two. But then it's cheap. The transactions are cheap. It's super fast. It's fraction of a second. And I mean the finalization obviously will take time, but yeah, I mean it's very fast, and you can use it today. So make sure you go and try both of them out. Um, do we have any questions before we move forward? Um, I'll just give probably a couple of seconds more. All right, good. So coming to the interesting part, yeah. Vinayak, give it up. Go to the how we get started.
Uh, yeah, yeah. So, hello, guys. Any questions till now? It seems like we have an audience that needs some work here. Might we might have scared the audience too a bit.
Yeah,
It seems like that. Let me clarify some of the things here, right? Real quick, right? So what we can do is, I think people, if they might, okay, there is no sir, okay.
Hi, I,
No sir for what? No sir for questions or no sir for that?
I wanted to ask, like, what is the need for fees?
Hmm.
Because when mining a block, you get Ethereum anyways. So, yeah, the fees is a deterrent for many people. Like, the fees is like $20, and they feel like we are giving away money, then we could use a debit card or something.
that's a great question actually. Vinay, do you want to take it or should I?
You can take it for sure.
Cool. So yeah, you asked why fees, right? So fees are something you give to the miners for miners mining the block. They do their job, they get some payment out of that. That's one use. But why gas is actually useful is because you're paying gas for using the Ethereum virtual machine of Ethereum. So you don't clog up the network. You pay for what you use. So when Vinayak has to send a transaction, I can't block. I can do a denial of service attack on the network and make Vinayak stop doing his transactions. So the gas fees are something to protect the network in addition to uh, pay the miners. But something very interesting is EIP 1559. Uh, please don't look at it now. But yeah, I mean, probably after you guys
Yes.
do a lot more, it will be very interesting because that changes the gas logic a lot
Hmm.
and makes so what it does. I'll tell you. So it makes the gas curve smooth. So the gas prices they fluctuate a lot because it depends on what Vinayak is paying and what I'm paying, right? So what EIP 1559 does is it, according to the network stats, it smoothens the curve. So there's no random spike up and down, and you get reliable gas feeds to use the network. Does that answer your question?
And like one more thing, like, why couldn't we just do the transactions or the contract execution in a chronological order? So, like, no preference.
Oh,
Yeah.
do you mean why we couldn't do it in a chronological order?
Yeah.
Because in blockchain is a distributed system, right? So there's no concept of timestamp. There's nonces, which Vinayak told you about. So nonces are also there's also a nonce which is associated with an account. So that takes care of the sequence of your transactions. So let's say Vinayak wants to send a transaction, I want to send a transaction. You pass on the transaction, you propagate the transaction, but there's no central time that you can look at and say, Vinayak send it first or I send it first, right? So in a distributed system, you can't have a central time. So there's no chronological order unless the miners put in a block. And there's a nonce associated with that. So I try to change the question up a bit, but yeah, hope that answers your question.
I thought that the all the blocks had a timestamp with them. So,
That's true. That's true. All the blocks have a timestamp. So once your transaction is mined to a block, the block will have a timestamp. But say your transaction is not put in a block yet. It's on the mempool. Mempool is a temporary place for your transaction to follow. So where miners come and pick it up. Okay. So whenever a transaction is lying in a mempool, let's say you have Vinayak's transaction, you have mine. Now miner's job is to put them in a block, arrange them in a block, and append it to the chain. But the miner doesn't have any clue if I mean Vinayak's nonce is correct or if my nonce is correct because there can be two Vinayak's transactions that were sent at comparable times, but he doesn't know which one to pick unless there's a nonce. And the timestamp comes after you include the transaction as well. Vinayak, do you have anything to add to that?
Yeah, sure. If I talk about some of the logics behind it, what I feel is that the chronological order, one of the things that I feel is this particular thing is done by because to incentivize to incentivize the miners as well, right? If you see the logic behind it, it's quite optimal, right? So gas fees they vary because the miners they should be incentivized accordingly, like how much transactions coming and how much transactions are outgoing, and the transactions that are higher gas fees will incentivize the miners to. So in that particular case, the incentive of miners is retained, right? If there is variable gas fees and there is no chronological order, instead with the order that is being decided is decided by the miner himself, right? So if we think about the logic behind it rather than the technicalities of it, I think this is how the whole structure is actually working. To add on to you, this is what I'll say that in the why the stuff does not really happen in the chronological order instead. I hope we have cleared your queries. Do we have more?
Yes, sir. I was just thinking about the perspective of the users so instead of the
Yeah.
miners.
Okay, yeah, so that's why, if you think about miners who, like, the proof of work system is actually based on, it's a combination of thinking about the users as well as thinking about the miners themselves. So it's not just to incentivize the user with security and the things that they have, but also to incentivize the miner on the other end, so that his incentive to mine is still there to the network. Otherwise, the transaction will be clogged. There will not be miners, right? So these are the logics behind what happens. So both of them should be given some equal priority. So in the chronological order, what will happen is that the fees that there is will be coherent, right? And it has to be coherent, or will be dependent on how much the system is clogged, right? Instead, if you vary the fees, then the system in itself creates a space for large fees transactions will go ahead first, and then the small fees transactions will come into play. So if you think about it, it's quite smart. Uh, you know, um be happy that some of you might actually develop something like that. So one of the smart, you are amongst the smartest groups that there is, right? So you already proved it because you are in such a prestigious institute right now, right? So someone of you might be responsible of creating something like this. So how smart is it if you look at it that way, right? So this is why to if there are questions, please, they are welcomed. Then
Hello. If
yeah.
I try to put OMG on the blockchain trilemma, so since it moves a bit towards scalability, I think it would it be right to say it's moving a bit far away from decentralization or privacy,
That's
although I can see privacy in the OMG X part.
That's an amazing question. I'm glad you pointed out the trilemma. So, to give you a background of the trilemma, so there's this triangle which says only two of those sides are possible. The triangle includes decentralization, scalability, and security. So, we know what scalability means, we just talked about it. We know what decentralization means, and we know what security means, of course. We know. The theory says you can't achieve more than two at the same time. So with Ethereum, it's decentralization because it's pretty decentralized and it's secure. So there's security. But yeah, there's a simple trade-off in the scalability part. So what Plasma or any layer 2 solution, what it does is it doesn't really trade off the decentralization part, but tries to make it pseudo. So it can be verifiable. So with OMG Plasma, for instance, you have to decentralize. You have scalability because that's what we're talking about. You have security, and then about the decentralization part. Since there's an actor called a plasma operator who operates the plasma, who's taking care of your blocks. So you're supposed to think that's centralized, right? There's someone taking care of the blocks. So it's centralized. Someone single is taking care of everything. But yeah, so we really go around the problem. We don't deny the triangle, but what we say is, even if there's a central agency who's doing it, you can always go and verify and prove them wrong, and then you find the safe. So that's a very smart way of um, going around the problem of the trilemma. Um, any more questions? These are really interesting.
I think that is it, right? So, guys, even though if you have not understood the words that there are here, right, we'll be sharing with you guys the links of the groups where you can join, stay in the community and ask your questions. Please ask them as many questions that you want to ask, right? We'll share the link to the Telegram group. We'll share the Discord group for the OMG as well, where you can actually connect to, experienced developers that there are, right? And then you can have a conversation with them. You can even ask them about their experiences. I think they'll be more than happy to share their experiences too, right? And to help you guys onboard blockchain. One of the most important things, one of the most beautiful things about crypto market is that the community there is very, very helpful. So they'll help you guys to grow, to even to get started, right? Just make sure that you guys stay connected. That is the most important part. If you are connected, we'll definitely be able to help you one way or the other, right? With this note, I think we can end the conversation. Thank you guys for having us here, right?